Hey, geometry, here's your notes for section 4.3. We are going to be talking about transformations and congruence. A transformation, a rigid motion, is a transformation that preserves length, angle measure, and area. So the length of anything doesn't change, the angle measure doesn't change, the area of the figure does not change. Another word for the rigid motion is isometry. You won't see that very often, but every once in a while you might run across isometry. It's just called a rigid motion. Some examples of rigid motions: you could use translations, rotations, or reflections, and we're going to talk about those and the difference between each one. This first one, starting with the blue drawing and going to the red drawing, that is a transformation. All that happened is you took this figure, slid it in this direction of the arrow, and moved it over to this spot. You translated it to another position on the paper. Translation. Reflection, same idea as a reflection in a mirror. For a reflection, you have to have a reflection point, or in this case, a reflection line. Where are you reflecting it? What are you moving it over? So you're taking this blue figure and reflecting it over to the other side. Not just moving it to the other side, but actually turning it over and flipping it to the other side. So that is a reflection. But notice it is still same size, same shape, same area. And the last one we said was a rotation. A rotation is a little bit different in the sense, well, kind of like a reflection. You're going to need a point. Go ahead and draw a point down here on this. A rotation point. You can't just take something and be like, oh, I'm going to move it, rotate it. You have to decide what you're going to rotate it around. So you would take this blue figure, and if a string were tied to it and tacked down right here, the whole entire blue figure would just rotate and spin around this string, around this tacked point, and finish over here on this side. So as you can see, it's rotated and moves about this way. So that's what a rotation is. And a rotation could go this way, but it could also go that way. You're going to be asked to describe the transformation you can use. You're starting with the blue figure onto the red figure. The arrows kind of show it to you that way. So this one, it makes it very obvious with the point P that it's tacked down right there. The blue figure is going to rotate onto the red figure. Therefore, it is called a rotation. This one's got two arrows. So you take the blue figure, translate it over to the green figure, then reflect it over that line. So when it says describe the transformations, you would say it's a translate, or translation, we'll use the full word, translation, then reflection. Translation, then reflection. Would you end up at the same spot if you would have reflected it first and then translated it? You would have, but that's not the way that arrows went. It told you that you were going to translate first, then reflect. Same thing over here. You've got two different arrows, which means you have two different rigid motions. First, we're taking the blue and translating it. So we have a translation. First translation, then spin it around point P, which makes it a rotation. Translation, probably should say then rotation. And the last one, again, translation, down to the green, then, and we took the green and reflected it over the line, so translation, then reflection. That's it. You're going to have to be able to identify those and make sure you spell them right.